Okay, we're here with George Kizer, the author of Digital Microwave Communication, and our main contributor to this online course that we're going to be presenting. And we thought it would be good for the student to hear a little bit about George's background and understand the man behind the material. So we're going to ask a few questions of George. George, first of all, what motivated you to develop this course and write your book?
Well, Joe, when I started this business 40 years ago, there weren't many books on microwave communication, and there certainly wasn't much information on best practices. I was thrown into some very interesting projects and had an opportunity to learn quite a bit, but it was a little tough. I'm convinced that experts are the guys that make the most mistakes, but learn from them. Well, I made plenty of mistakes, and it was tough going. So I'd like to share what I've learned over the years, and hopefully some of the engineers coming up can learn from what I've experienced and not have to spend as much time in the learning curve mode.
Makes sense. So George, can you tell us about a practical experience that contributed to this course?
Well, Joe, I'll just talk to you in general about a few cases. When I started, I didn't know anything about microwave, but I was in the Air Force and Project Scope Creek, and I went out with some master sergeants, and we tested microwave links all over the world. And those guys taught me a lot about microwave. After that, I got into the private sector and started designing microwave systems for Rockwell International. I was designing national and international systems. Yeah, I had an opportunity to do many large projects, but again, I didn't know a whole lot about it, so I had to learn a lot. And occasionally it was school of hard knocks. Sure. So I'm hoping I can pass along some of that experience.
So what are you hoping a student will take away from going through this course?
Okay, well, when you take this course, I hope you understand that microwave path design is both a science and an art. It's a little of each. But reality isn't in the software, and it's not in the office. Reality is what happens out in the real world. So if you could just place yourself out in the real world and think about the environment that you're in when you're designing these microwave paths, I think it helps. Because the microwave path is an amalgam of many different characteristics. And what I'm trying to help you understand is the characteristics that are important and the ones that aren't. But every path is a little different. And so you have to think about each one of those paths and the important characteristics that go into making a good microwave path.
That makes a lot of sense. So going to the technology side of it, do you think there's any one big breakthrough that would take microwave to the next level?
Well, in terms of a single breakthrough, probably the thing that's most important right now is adaptive modulation. Adaptive modulation, coupled with the wide range of modulation schemes that you have, allows the paths to have much higher bandwidth, but much lower threshold and much deeper fade margin. That contributes to very high bandwidth and very reliable paths. An amazing combination, something that's really a game changer relative to what we had 10 years ago.
Yeah, we're seeing a lot of those being put in today. So
they're very important.
Yeah. So what do you think the future of microwave looks like based on the trends that we're seeing today?
Well, microwave is definitely continuing to progress. You see that there are a couple of things that are very important. It's first of all, bandwidth. We're figuring out ways to put radios on paths to get the bandwidth up above a gigabit per second. That means we may be stacking radios, we may be using very wideband, high-frequency radios, but that's very popular. High bandwidth is extremely important. The other thing that we're seeing is it becomes harder and harder to get low frequencies, is we're using higher frequency radios, but we're taking advantage of architecture. Architecture is something that we really couldn't leverage 20 years ago, but can today. Mesh networks with MPLS routers allow you to put together networks that are extremely reliable, even though the individual links may be impaired for short term by propagation anomalies. The impact that mesh networks can give you for the relatively long outages that you see with rain, for example, is very important. You can create very reliable networks with very high frequency paths. And that, coupled with the bandwidth, gives you very strong high bandwidth networks.
Great. Well, George, thanks so much for your contributions to the industry and to this course, and we hope the students will take a lot of this information and be able to learn from that and progress in the course. Thank you.